screen where we will have an opportunity to also get the slides, okay? So hold on a second. Yeah, and you can see my screen here. Okay, hold on a second. Okay. Hold on. Okay, this is the slides. Hold on a second, I need to reshare again. Okay, now it's much better. So MicroProfile is a specification, right? I'll go deep on that, but you will see today from the 1.0 specification, from the beginning of the specification, from the version 1.0 to the version 5.0, okay? My name is Rafael Benavides, as you have probably seen in the invitation. Today I work at Microsoft, I work at Oracle, and also at Red Hat. And if you want to get in touch with me, you have here my email and also my Twitter, okay? And another thing that you might like is to get these slides, because you'll see a lot of examples here from the MicroProfile specification. If you want to get these slides, you can go to this link here, bit.ly/slides in plural, MicroProfile /slides-MicroProfile. Okay, so let's go. Well, I started telling you that MicroProfile is a specification. So how that happened? Because for many years we heard about Java EE, Java ME, Java Micro edition, which is not, there's nothing, there's no connection with microservices. It was for micro devices. We heard about Java CE, Java Standard Edition. And there was a moment close to Java E6 where the Java E6 was too heavy, and they decided to spread in two minor specifications, which was Java EE6 Web Profile and Java EE6 Full Profile. Keep that in mind, because this is important on how MicroProfile was created. Okay, so the Java EE Full Profile was the complete set of enterprise specifications for Java transactions, messaging, Java server pages, servlets, and so on. And the web profile was focused only on what technologies and specifications you would need to create web applications. So it was servlets, JSP, JSF, facelets, and so on. Okay, JPA for database connections, and so on. But there was a moment where when Oracle bought Sun, the community felt that there was a lack of a lack of specifications for using Java to create microservices. Of course, there was the Spring framework with the Spring Cloud and so on. There was the tiny frameworks like I can't remember the name at this moment, but the community felt that they needed a specification, something that many vendors, individuals, organizations would join and define what would be and how would be to create microservices in Java. So that was created in this moment where this community felt the lack of this specification. And to start this specification, some companies like Red Hat, Microsoft, Oracle, they even sold Java, which is a jug here in Brazil. IBM, they joined it and decided to create that specification focused on microservices. Okay, and because microprofile is a specification, it's very natural to have implementations of that specification. So each company, they can create their own implementation of that specification. That's what's happened, where you can see in this slide. For example, Red Hat created Tornado and Wildfly, and Quarkus also. IBM created Open Liberty. Apache created Apache Tommy. Oracle created Helidon. Payara created Payara Micro, and so on. Okay. So when this group of companies and individuals decided to create the specification, they reunited and released the first version, the version 1.0, on September 2016. It was during the Java 1 of that year. And they didn't decide to start from the scratch, because if you get the Apache, the Java EE specification, you can use some technologies to build microservices. For example, usually when you are communicating, creating a microservices that has an endpoint using JSON, you can use JSON-P to provide the integration with JSON. If you are creating a REST endpoint, as I mentioned, you can use JAX-RS. It's an awesome specification for REST endpoints. You can use CDI to define the context and the dependency injection in this world of specification. So this community decided, okay, the MicroProfile 1.0 will get CDI, will get JSON-P, and will get JAX-RS, and create the first release of MicroProfile 1.0. Of course, at that moment, I was there. By the way, I was at the Java 1 of that year. And of course, many people was not okay, but what should I do with just 3 specifications when I have the Java EE full of specifications, when I have a Spring full of technologies, with Spring Cloud connected with Netflix OSS, for example, that has a lot of things. But that was just the beginning. They needed to start from somewhere. So after almost 1 year, 11 months later, a new specification has been created from the scratch. This specification is called config, because let's think about microservices. When we have a cloud native application, we need to move from environments to environment. We need to have a complete set of microservices in the developer's machine, that they are configured to run locally. When you move that to another environment, you need to change database connections, service URLs, messaging queue names and servers. You have to change a lot of things. So, and then when you move to production, it's another set of changes. So configuring microservice is very important. So that's why it was the first specification created after that. Remember that I told you that I will show a demo that will help us understand MicroProfile as a whole. So before moving forward in this config specification, let me show you the demo application, okay? So I have here in my terminal 3 Java applications running. I have one microservice called customer, which can be the microservice A. Okay, let's start it. We have another microservice running here, which is the preference, which is can be the microservice B. Okay, let's execute it. And we have the microservices C, which is called recommendation. Okay, so it's A calling my microservice A, calling microservice B, calling microservice C. Just regular REST endpoint where we can call it and it will get all the replies and show it to you. So let me show that. Let me execute. Okay, if I go to this URL localhost on the port 8080/API, you can see that customer called preference called recommendation version 1 from Unknown. It's an Unknown host because it's running locally. It's not a container, nothing like that. And it replied with a counter. If I refresh that, it will reply 2 and 3 and 4 and so on. Let me move here. You can see even here the logs working. Okay. So why I showed you that? Because, for example, I told you that we need to change the configuration when we change the environments. And also, we need to get that information from somewhere. We need to have config sources. What are the sources that will provide me this configuration? And MicroProfile gives us 3 config sources. And they have an order. You can see this order here in the ordinal, where the higher number has a higher precedence, which means that if I specify here, I want to get the URL from the preference API. Remember, customer calls preference, that calls recommendation. Now I need to know, I want to get what is the URL of the preference endpoint. So this key here, the key preference.api.url, can be located on the microprofile config .properties file. This is the least in the order. But if I overwrite that, creating an environment variable that has a higher preference, it will overwrite any value that I have in my machine. So, for example, I can have a default value, but if I change that to a Docker container, so if I change that to a Kubernetes cluster, I can create in the Kubernetes file an environment variable that says my preference API URL is preference slash the name of my namespace dot the name of my namespace dot services dot local, for example. Or I can, if I'm just debugging this locally, I can overwrite without changing the file with the system property. So instead of saying the name of URL here, and you can see, let me open my Visual Studio Code. You can see here in my code that I have exactly what I have in my slide. My preference API URL is localhost 8080/81. But if I want to just do something quick, instead of running java.-jar, I can use a system property, preference dot API underscore API underscore URL equals ABC. This will overwrite the destination of my endpoint. Let me see if I can make it work. It's given. Probably I missed something in this definition here. Okay, I can't remember if it's like this. But that's just an information. It's not. You just need to know that I can inform a system property and change the value. Okay, or I can do it like this: export preference dash underline API. It's API URL. Let me get it. API URL. API URL equals anything. Let's see if I can make it change the behavior. Yeah, it's not working anymore because there is a environment variable that sends me to another place. So on export, on set preference API URL, and let's execute. And now that I don't have anything overwriting my URL, I can make it work. Okay. Well, you can integrate the config API with CDI. For example, I can use produce to create a transport client, for example, a client, a REST client, anything, Kafka client, and I can provide that configuration using the config API. So you can provide, for example, the cluster name, which is CDI. I'm injecting that configuration. I can provide the host name, the host port, and then use those variables and produce a client. Okay. You saw here in my example that I injected the string value of the API URL, and I used that string to create a URL to connect my REST client. But I can also inject, if I need, the config object. Sorry. So with the config object, you can, for example, get the property names. You can get the config sources. By the way, you can create your own customized config source. For example, to read the configuration from a database. That's possible. Okay, the MicroProfile API is extensible. You can use the get value, okay, or do like you saw, just inject a string, a boolean, an integer, okay. You saw that it took like 1 month to create the first API, but that was because they are just getting warm up. After it's just like a project in your company. After you have your first project running, it's easy to create the other project. So this is what happened to the Eclipse MicroProfile 1.2, because 1 month later, they released 4 new specifications. They released the health check, the metrics, the fault tolerance, and JWT propagation. And we'll see each one of them now, because let's think, if we are building microservices, we need to understand if the service that we are trying to reach is health or not. The idea of this health API is not only provide to a human the notion of the service is healthy or not, but also provide to other computers if the service is health or not. Okay, so for example, if we use Kubernetes, Kubernetes can use liveness probe, readiness probe to understand, is my service ready to receive requests? Is my service live? If it's not live, I should restart the container. Okay, so it's very likely appropriated to machine communication, but also provide enough information for a human administrator. And how these health checks are defined? Just like Kubernetes, in MicroProfile, we have the notion of being live and being ready. You can create your own health check. Of course, if you use MicroProfile, there will be predefined health checks for you. For example, let's see if this application is live. Let's open. We can see a JSON file here. And it says, okay, it's up, it's live. And why this is saying that's live? Because there's some checkers, and all checkers said that they are up. Deadlock, no, there's no deadlock, so it's up. Is the disk space enough? Yeah, and I have the data here. Is the heap memory okay? Yeah, it's okay. So it's up. So everything is up. Or I can say, is it ready to receive requests? Yes, it's ready to receive requests because it can communicate with the preference. The preference availability is up. Okay. Another thing that we should consider, if I go to this page, network, yeah. If you go to this page, you can see that the status is 200. So as a human, I can see that it's up. If I was a machine, I can see that the status is 200. I will stop. Is there a problem? I heard that the recorded stopped.
No problem, no problem. We can go ahead, Profile.
Okay, thank you. So what I will do now is stop my preference microservice. And now that it's stopped, I will try to check if my microservice A, the first of one on the port 8080, is ready to receive requests. If I try that, note here, it says preference availability. It's down. And the cause is connection refused. This is the information as a human. As a computer, if I reach this page, it will give me a 503 error. So it's giving me an error. I cannot. So Kubernetes can understand, based on the HTTP status, if this service is ready to receive requests or not. I cannot send requests to this microservice because it cannot complete the full operation because it's missing. Preference is not available, right? Note here that preference is something that I created myself, that I customized, because I can create custom checks simply by implementing the health check API. Remember, I have two health checks. I have readiness check and liveness check to define, and I have two different URLs. I have the ready and the live. Is my first microservice live? Yes, it is, but it's not ready to receive requests. That's why it's important to define if you want to check for readiness or liveness information. And you define that by using the annotation readiness or liveness. Of course, you can use both annotations at the same check, and the check will return a health check response. Note here that if I can communicate with preference, I just say, okay, response up. If I could not communicate, as it happened here, I say the response is down, but I add a data. I add the data calls, and the calls I get it from the exception. Okay, now let's make it run again. And now we can check, and it's ready to receive requests again. Okay, so it's very simple, but at the same time, it's very powerful. What about metrics? The metrics is to monitor endpoints, and the metrics of those processes. What are the metrics that we have? By the way, you can think, but Java already have a metrics extension, a metrics specification. We have JMX, Java Management Extension, but Java Management Extension is just for Java endpoints, Java applications, okay? It's not meant for a polyglot environment. Remember, in a microservice environment, we can have Java, we can have Python, we can have C#, we can have Perl, we can have Golang, we can have so many languages that we cannot rely on JMX. We need something polyglot. And this specification creates a standard way to see a standard for the API path. How can I know what are the metrics? What are the data types, what are the metrics that every vendor should implement, and what are the return codes used. So while we saw that the health check was a yes or no response, in the metrics, we have a trend data for capacity planning, for example. While in the health check, we say, is my application still running? Is it live, as you saw? In the metrics, we can see, okay, my disk usage is growing. So what should I do to avoid a problem like out of space? So there are some metrics, general metrics, like, for example, used heap memory, committed heap memory, JVM uptime, and so on. Class loading, total loaded, class loaded, unloaded, class count, thread count, pool size, active threads, metrics from operation system, the system load average is very important, process CPU load, and there are many metrics. So there are three sets of sub resources, three scopes. We have base metrics, which means that all MicroProfile vendors should provide. So no matter if you are running Quarkus, if you are running Helidon, if you are running Apache Tomei, or if you are running Open Liberty, they have to provide what has been defined. But suppose that Oracle decides to use an extra metrics and provide those extra metrics by default. Well, it's not part of the MicroProfile specification. So it goes to another URL, which is vendor/vendor. And suppose that you create your own metrics. You want to know business metrics. How many items did you sell? How much you how much you sold? You can create your own metrics and place those metrics under /application. So if you go to /metrics, you will see all metrics from this microservice, and you have here the description. For example, base class loaded, class loader, class count. The description says displays the number of classes that are currently loaded in Java virtual machine. Base CPU available processors displays the number of processors available to the Java virtual machine, and so on. So many metrics that you can, but you suppose that you want to see all metrics that are provided by this implementation. So this implementation, vendor request count, vendor request matter total, are only provided by this application. If you want to check what are those ones provided by MicroProfile, you can go to base. Or if you want to see the application, this endpoint does not provide any metrics for any customized metrics for the application, so it didn't return anything. And how you can create your custom metrics? You'll see that. Suppose that you, as I told you, you want to create a custom metrics that will provide information on how many requests you had on that microservice. You just need to provide one of these annotations. You can annotate your metric, your method with counted, to count how many invocations it had, how many invocations on that object. You can annotate with gauge. You can annotate with metered, and you have also to declare the unit. You have the full unit for metered is per second. You can have per minute, per hour, so on. Metric, or timed. And you can see here, let me show you the microservice C recommendation endpoint. I place it here. This is count. I have an annotation counted on this method. So every time that I access this endpoint, it will increment that with a matrix that says recommendation count with the number of invocations. So for example, let's invoke my API. It says that every time that I access it, it increments the number. So you can see 22, 23, 24, 25. But if I go to my microservice C, which is on the port 8082, and get the matrix application, you will see something very funny here. You see that the recommendation endpoint, recommendation count total is 49. And plus, this metric is totally standardized, so I can consume these metrics in Prometheus, for example. If I go to Prometheus and request that this recommendation total, you can see that in a graphic. So remember that when I stopped it and I started and did some invocations, now it has, let me reduce here, and now I have 49 recommendations, right? And I will do one more invocation here. The invocation, hold on, 26. In a couple of seconds, this metrics will be updated and Prometheus will get it. And you can see here now that is 51 invocations. And you can ask me why, and pay attention to this, why I have 26 invocations on your API as a response, but the metric says that I have 51 51 invocations. Keep that in mind. You will understand why, because that's what we will see in this next next specification, the fault tolerance. The idea of fault tolerance is because in a microservice world, we don't try to avoid failures. Failures will happen. The problem is what we will do if it happens, because it will fail. Okay, so we have some things, some technologies in the MicroProfile world to provide retry policies, to provide bulkheads, to provide circuit breakers. So these are the 5 annotations that you can place on your microservice. You can provide a timeout. Suppose that you are handling a credit card operation and it's too slow. It's taking 30 seconds to reply. You don't want to make your customer wait 30 seconds to load the page. You can provide a timeout. And when the timeout happens, you can reply to the customer saying, we are processing your payment, and check in some minutes if your payment was processed or not, and so on, and send that to a queue to be processed asynchronously. You can provide a retry. What will happen if my microservice is failing? A fallback. If it fails, what should I do? A bulkhead to isolate failures in a part of system while the rest of the system is still working. Or a circuit breaker to provide a sliding window where if there is an amount of failures in that specific sliding window and in that specific time, it will open the circuit and avoid sending requests to that microservice and provide a fast failure, a fast response to that specific failure. Okay, so you can have, for example, this method here. It's a timeout of 800 milliseconds, less than 1 second. You have a circuit breaker of where the volume threshold is 10, and in 10 requests, if the failure is more than 60% in 2 seconds, then it will open the circuit. And only after two consecutive success, it will close the circuit again. But it will retry 5 times before giving up. And if it fails, what is the method that will invocate? In this case, it will return the default author. Note here something very interesting. In my Microservices B preference that calls recommendation, I have placed it here retry of a timeout of half seconds, okay, 500 milliseconds, and a retry of 5 times, okay. And if it does not work, if it fails, what it will happen? It will invoke a method called fallback. And here is my method called fallback. It just returns fallback method. So everything is working here, as you can see, right? But I will stop preference at this moment. And now that preference is not working, when I try to invoke, immediately, because my timeout is 500 milliseconds, it will not wait. And after less than 1 second, it will return the fallback method, right? But another thing that you should see here is that when I am executing this operation, right, I place it, because I want to test it, a misbehave flag. The misbehave flag sets the flag to true and then to true and false, true and false. So every request, it fails. Another request, it works. It fails, it works. It fails, it works. But why I don't see this failure here in my API, right? You can see 6, 7, 8, 9. I don't see the failure, because when I get, for example, let me access the API directly, okay? 8082 API, misbehavior, behave, misbehavior, behave, misbehavior, behave. I didn't see the misbehavior because it retries. If I get anything else that are 200 HTTP status, it will the Microservices B will retry the connection and retry until it works. That's why until 5 times. That's why I always see it working. Okay, it works. It simply works, no matter if my Microservices B is failing. So that's great. That's really awesome. Okay, for security, as JWT, JSON Web Tokens, they became the standard for microservice security, because you can just propagate that token to different microservices. MicroProfile also comes with a specification for JWT propagation. So first, what is a JWT? As I said, it's a JSON Web Token. It's an open standard and it's meant to provide some informations about authentication. So for example, if you go to jwt.io, you can get a default JSON Web Token here, where you have the subject, you have the name, you have EIAT, which means issued at, and you have you can have a lot of other payloads. You have the header, which means which algorithm you used to create that token, and you have the signature. If you change anything here, a simple letter, it's an invalid signature, and you cannot use that JSON Web Token because it does not match on what you wanted. Okay. So now that you have a JSON Web Token and you send a JSON Web Token in the header of your application, MicroProfile will automatically consume. It will use the sign key that you used to verify the signature of this JSON Web Token. It will open this JWT, and you can get, based on the roles provided by the JWT, what are the roles, and you can take your method and say, you will only provide access for user and admin roles. For the all others, it will be denied, right? You can get the principal that used to access that method. And you can even get the token, right? So it's very interesting in the microservices world. And we are only at the MicroProfile specification 1.3 now, in January of 2018. And don't worry, we'll reach 5.0 until the end of this webinar. But what you need to understand now is that for MicroProfile 1.3, it came with open tracing, open API, and REST client as a new specification, right? Open tracing. If you have ever worked with Swagger, you can think about Open API as a specification of Swagger, right? You just need to use, basically it's the same annotations of Swagger to define, to annotate, to create a documentation of your application, of your API and your methods. Like, for example, the tag name, the operation, the API response. And then you can consume that. For example, let me show you my customer endpoint. I have here the tag customer serve description, get customer reference and recommendation when I access /API. I have redefined which is the version, who is the contact, and automatically, if I go to Swagger, for example, and again, I'm using Swagger, and get the Open API from, for example, let me get here. If I go to Open API, it will try to download. But if I open to Swagger, I will see exactly what I defined in my code. This is the customer service, and this is the customer microservice. This is my contact information, my website, my email, the email and the website of the developer. And I can also see information about this, my service. The only service that I provide is the get method in the /API. That takes no parameter. I can try it out here. I can execute. It will give me the call command. There you can, and what happened when I invoked the response body is the invocation, the headers that came with 64. Response was okay. So it's very nice for those people that are providing information of your microservices to clients, to customers, especially clients, right? Well, what else we have? We have the REST client, which is, of course, to create a REST client, of course, and we have the JAX-RS have a 2.0 has a JAX-RS specification for clients. But the idea of MicroProfile is create something more type safe. So, for example, you can create an interface like I did here. Let me show you a client. I have my customer will invoke preference. So I have the interface, the remote interface that represents my microservice B. So I have the method get preference that throws a preference exception that returns a string. I annotate this interface. It will return me a text plain. I will access that as a get method on the path API, and I registered that as a REST client. Here is just the preference exception that extends a web application exception, right? And I can just use this to consume my preference service. I create an instance of this interface, and I can just invoke that in a type safe way. So that's the idea of the REST client. And finally, I have open tracing. For those people also working with microservices, it's interesting to understand the flow of A calling B, calling C, that calls X, that could call X, Y, Z, and so on. So the open tracing, you just need to annotate the method with the notation traced, and everything will be traced. How do you mean, Rafael? Let me show you. The open tracing API can use different tracers. We have Lightstep, Hawkler, Datadog, Jagger, Zipkin for those that work with Spring Cloud. You probably have been very familiar with Zipkin. But now I'm using Jagger UI here. And if I open Jagger UI, and if I want to get my service, my first service is customer, and I want to find all traces, I can see here all the traces that I did along my demo, right? And let me see here. Let me get this one which failed. You can see that customer called preference, and remember that preference does a misbehave. So the first thing that it returned was a misbehave. You can see here, even in the logs, an error, right? It returned a 503 error. And then you can also see that preference performed a retry after the misbehave, right? So we can see here that the second invocation returned as okay, and so on. So we can even evaluate the total amount of time spent for each one of these specification. Of course, you can see for the misbehave, we have 22 milliseconds, and then 5 milliseconds for the behave method. Okay, so it's very interesting also to debug in a microservice application, in a microservice environment, right? Okay, for MicroProfile 1.4, we didn't have anything new. We just updated all the previous specifications that were in 1.1, 1.0 to 1.1. MicroProfile 2.0 included, in fact, JSON-B from Java EE. So the idea was create an alignment with Java EE related APIs to Java EE 8 release. So it has been updated CDI, JSON-P, JAX-RS, and added JSON-B. For MicroProfile 2.1, nothing new, just another alignment with Java EE, and now Jakarta EE. Remember that we moved it from Java EE to Jakarta EE. Then also nothing new on MicroProfile 2.2, right? More alignments and updated APIs, existing APIs. The same I can say for 3.0. And on MicroProfile 3.1, there was another thing that has been introduced, which is the idea of specifications that are outside the main umbrella of MicroProfile. So we had the introduction of reactive messagings, context propagations, and reactive streams operators, right? So I will not spend time mention each one of these specifications of the outside umbrella, but we can see that MicroProfile 3.2 was just updated, 3.3 updates. MicroProfile 4 has been released on almost in the beginning of 2021, December of 2020. So more updates of APIs, 4.1 update of APIs. So now we have health 3.1, config 2.0. So things get more mature. And finally, MicroProfile Sync 5.0, which is the latest one, where we have a complete update of MicroProfile to match Jakarta. So we can see that's based on Jakarta CDI, Jakarta JSONP, Jakarta JAX-RS, Jakarta JSONB, and Jakarta annotations. Okay, and the outside umbrella is a little bit. There are some more technologies also: reactive messaging, reactive streams, context propagation, GraphQL. It's very interesting, and LRA, long-running actions. Okay. Well, and just like Spring, you can go to start.microprofile.io to create easily your project. You can select a MicroProfile version. Let's see if there is a runtime. Just Open Liberty provide a runtime for MicroProfile 5.0. Let's see MicroProfile 4. Yeah, we can choose here, for example, Wildfly, select the version of Java, select what are the APIs that I want to use, and just download my pre-configured project. By the way, the demo that I used today, if you like it, you can go to this URL here, /rafabene/microprofile-demo, and you will see the source code of customer preference and recommendation. And something interesting that you can note here is that I started this project long time ago. You can see by my commit history that this project has almost four years from my first commit. And I started this as a Torntail application. Then later, I was working at Red Hat. Red Hat released it to Quarkus. It was very easy to migrate to Quarkus. I basically just switched the POM XML. Then later, I joined Oracle, and I wanted to try Halidon. So it was easy to try Halidon because I just switched the POM. Just a minor changes in my source code. And that's the beauty of using a specification. It's the same project for almost 4 years. It has been updated from MicroProfile 1.0 to 5.0, and I didn't need to rebuild it from the scratch. It's very hard to have a legacy code when you are using a specification. It's hard to have a technology that will be deprecated. The idea is just to evolve the API, right? And also, if you want to get in touch with the MicroProfile itself, you have here in the slides a link to Google Groups. You can go to the MicroProfile pages and see all the projects and probably join any one of them. Okay, they have meetings, a YouTube channel, video hangouts. You can just go. And also, as my last my last invitation is to open Twitter. If you have Twitter, if you like Twitter, you can go to my profile at Rafabene and click on follow, because I like to talk about cloud native applications, cloud native technologies. At this moment, I'm a cloud solution architect at Microsoft, so cloud is being part of my daily work, and I really like what I do and I want to share those knowledge with the community. So you will be very welcomed if you can follow me in this link. So I'm stopping share my screen here, just in case if you have any questions. If you posted any questions, please let me know, and I'll be very glad to answer. Otherwise, I appreciate. I'm really thankful for watching this webinar.
Hey, thanks a lot, Rafael. No, fantastic session. Really enjoyed learning how to use the MicroProfile services, and also especially because a lot of the programmers who do Java microservices, they're still struggling, right? So they know Spring Boot, they know they do Spring Boot microservices, but then the point at which they have to really talk about using cloud services and stuff like that, and that's where they really struggle. So I think, really, really fantastic session, especially when, the part where you showed how to recover from failures gracefully, and then, the retries and that sort of a thing, happens all the time. But yeah, I mean, really, really enjoyed the session. Very insightful.
I'm very happy that you enjoy it. And as I said, I also hope that everyone who watched it enjoyed it as we both did.
Yes, absolutely. And then this a recording of the session will also be made available to people on our community a couple of days from now. And one request for all the participants is to do follow Rafael on his Twitter. It's very I mean, his tweets are very interesting. I follow you, Rafa. So I really like enjoy your tweets, yours, and then there's another guy called Josh Long. So whenever something comes up, I make it a point to read it. Whatever I'm doing, I just drop that and then read what you've posted. So I encourage everybody to follow Rafael at RAFABNE. So you should have no problems looking it up on Google and finding it. But yeah, I mean, I do strongly encourage you to do that. Thanks a lot, Rafael, and then we hope to kind of bring you back for another session very soon.
Thank you for the invitation.